Well, okay, I guess we're going to try to finish off this chapter. I don't know if we've made it yet. I think there's 6 sections, so I don't think we're quite done, but we're making an effort. Now we're going to talk about a couple of biased sampling techniques, popular sampling techniques that don't actually work that well, but they're still often used. And we just have to tolerate the bias that might come about, because that's maybe about the only way we can get a hold of the information we want. So here we go. First, what's called convenience sampling. So that says we contact individuals in a way that is easiest, but may leave some individuals unrepresented. Can't write. Unrepresented. So maybe you're trying to figure out the outcome of an election, and maybe what you do is you go and you stand outside the grocery store, and you have your little clipboard, and you ask folks as they come in the store, can you answer a few questions about how you're going to respond to these ballot issues that are coming up at the election? And of course, you only get people going into the store. You don't get people that are working at that time. You might get, you don't get the opinions of people that don't shop at that store, they shop at some other store. It's just convenience sampling. You go there, you stand there, you get your job done, you collect the opinions of maybe 200-300 people. You do it in a couple hours, and so it's easy and it's cheap, but maybe not very accurate. And then there's what's called voluntary response sampling. Here, the individuals must choose to respond. So what might you do? You might say you might be requested to go to a website and respond to some questions. You might be watching a movie, and they might ask you to call in and find out about cheap insurance you might be able to get. But you have to be the one that makes the effort to respond. They might say, we're really trying to get your opinion on a certain issue. Please call in and make your ideas count. Things like that. So call in web-based paper forms that need to be filled out. So what happens here, of course, you're not going to get the opinions of most people because they're just not going to do it. Usually, only people with strong and mostly negative opinions respond. Oh yeah, our teaching evaluations are like that. We get a pretty low response rate. Sometimes the students that respond are part of a class where doing teaching evaluations. This is part of the class activity. But otherwise, you might not decide to respond unless something bothered you about the class and you want to register your opinion. Otherwise, you go whatever. It should be okay. So that's voluntary response sampling. The opportunity is given, but you have to make an effort to use that opportunity to get your opinion registered, and most people aren't going to do it. More discussion over here. It says biased sampling can cause the sample not to reflect the population. Right, so these two ways of sampling, you can think about as to collect information. I should move this. you can think about whether or not that particular style of collection of information based on the kinds of things you're trying to find out are legitimate or not. Probably not with convenience sampling or voluntary response sampling, but that's just how it goes. However, sometimes those things might be good enough. For example, you might wonder how people feel about eating at Chipotle, and maybe you go to Chipotle and you interview people as they leave. How was the food? Maybe that's a good way to do it, because that way you're getting the opinions of people who have just eaten the food. On the other hand, you're getting the opinions of people that go there to eat, probably like the food anyway. So maybe there's some issues with that. So that's what bias does. It can cause the sample not to reflect the population. And we don't like that because we're trying to describe the population when we do sampling. And if the sampling technique doesn't give you a sample that represents the population, then the conclusions you draw about the population from this sample might be wrong. But beyond that, all samples are subject to what they call random sampling error. So that says, more or less, that different samples will look a little different. So it says if you if you repeat the sampling process, you get different people, and they'll have different opinions, and you draw slightly different conclusions. So every time you sample, you know that sample isn't 100% reflecting the population because you randomly chose people somewhere. You select folks and interviewed them. You chose them numbers off a random number table. And if you did it again, you'd find different folks, different responses, slightly different conclusions, possibly. And so no matter how carefully you do things to make sure the sample is as representative as the population as possible, different samples look a little different and will give different values to statistics. So you're computing the mean, or you're computing the standard deviation, or you're computing whatever you're computing based on the data you're looking at. Different samples give different answers. So that random sampling error is accounted for usually by assigning what's called a margin of error. The margin of error to the computed statistic. So usually it says, say you were wanting to determine the outcome of an election, or you're trying to figure out what proportion of the population is going to vote for a certain ballot initiative. They would say that based on exit polls, that it looks like 68% voted in favor, and then they'll have a plus or minus here, maybe 3.5%. And that there is what they call the margin of error. So that says we know that 68% that we chose, and we computed in our sample, isn't the real number. But we also know that we did a good job of sampling, so that percent should be close to the real number. And so this gives us an idea of how close we expect it to be. The larger the sample, usually the smaller the margin of error. But lots of times with samples that aren't too big, the margin of error might be 3-4%. So if you're just worried about whether the ballot measure will pass, and you got 68% of the people in exit polling saying, yeah, I'm going to vote for it, and the margin of error is 3.5%, as long as this beats 50%, which it will, there's a good chance that the ballot measure would pass. And you could say with some confidence, if you're a news reporter, it looks like that's going to pass based on the computed percent from the statistic and the margin of error being looked at together, that the worst case scenario in terms of if you're worried about if this passes or not, that it'd be 68 minus 3.5%, which is way more than 50, and so we should be in good shape if we want that measure to pass. Okay, so that takes care of section 1.5, and I'll see you next time.